Pre-calculus, you did it. This is week 7. We've made it. This is our last lesson of quarter 4 in our crazy digital online learning situation. And you guys made it. I'm really proud of you. I hope you're proud of yourself. This was not easy to do, and but you did it anyway. It's pretty cool. Our last lesson is going to be something really interesting. So hold on to your hats. Let's do it. We're going to be looking at what's called polar coordinates. And polar coordinates are used in several things, but the one that always comes to my mind is air traffic controllers. So I have a little picture for you so you can get a kind of a visual. So they, on their screen, when they're keeping track of all their airplanes, they're using what's called the polar coordinate system. So it's circular, they're using angles for direction as well as a distance. So locations, they're using distances and angles at the same time. Pretty cool, huh? Yep, and we're going to look at it. We're going to study it. We're going to start it right now. Okay, so in our polar coordinate system, you're going to have your angle measure, and then you're going to have it's called a directed distance from the pole, or in our case, we're using the origin. So I'm looking at this isn't right here. We've got the R represents the distance from the origin for us, it says direct distance from the pole. And so that just depends if what situation you're in, but we are going to be using our origin. So basically the radius, how far are you from the origin? And then the angle, the second number in the coordinate, is going to be the angle from the axes, which in our case, x-axis, which is called the polar axis. Right there. Okay. So it takes a little bit getting used to when you're doing this. So make sure you're practicing, of course, taking your time. Anything new takes practice. So when we graph our points, we're going to first look for the R of, like on this point A, we're going to look for an R of 2, a radius of 2. So I'm going to go out 2 spaces here. I'm going to use my pointer so you can see what I'm talking about. So right here. So here's my origin. I go to the right 2 spaces. And then I want to go 45 degrees. So I'm going along this curved circle to 45 degrees. So right there is my point A. And I'm going to label that A, because we're going to graph all these points on our coordinate plane here. Our polar grid, I should say. Okay, B, notice how this time our R value has a negative 1.5. So that means we're going to go to the left 1.5. So if you start at the origin here, we want to go left 1.5 spaces. So that's our negative 1.5, just like it is on the rectangular coordinate plane. And then we're going to go, this is a positive 2 pi over 3, so we're going to go counterclockwise because we're going positive 2 pi over 3. And so that's about 100, that is 120 degrees as well if you want to go if you want to use degrees. So this is, so if I count it, so here's my pi over 3. And then I want to go to 2 pi over 3, right there. And so then that's going to be negative 1.5, 2 pi over 3. So you're counting from the x-axis and you're going counterclockwise 2 pi over 3. And it takes getting used to, again, like I said. Okay, so I'm going to go ahead and graph that point. So 1.5, 2 pi over 3, right there, and label it. Okay, our next point is 3 negative 30 degrees. So our 3, remember we start at the origin, and then we're going to go to the right 3 spaces. So this is an R value of 3. And then we want to go negative 30 degrees. So remember, negative is clockwise. So we're going to go clockwise 30 degrees. So there's 15, and then there's 30. So that's where my point C is going to be. Label it. C. Okay, we're moving on. You can always pause, try these on your own, and then, of course, check back in. Okay, so D is at 2.5, and then 4 pi over 3. So that's a positive 2.5. So here's my origin. I'm going to count over 2.5. So there's my R of 2.5, where I would start with. And then I want to go counterclockwise to 4 pi over 3. So 2.5. And then you can look at up top for the 4 pi over 3. We get to right there. And then we're going to label that D. Oops. And then our E is going to be at negative 2. And then negative 135 degrees. Okay, so our origin, and then we're going to go left to negative 2. So remember, you're going left 2 spaces to get to the negative 2. And then negative 135 means we're going to go clockwise 135 degrees. So that's 90 plus 45. And we actually end up at the same point of A, which brings up a really good or an interesting fact about polar coordinates. So rectangular coordinates, they're unique. Each set of points, or each set of coordinates is unique. But with polar coordinate system, that's not true. So just as we just showed that the point A and the point, this point A and this point E are actually the same point. So they have different coordinates, but they're same actually point on the polar grid. So we're going to practice now giving a different representation of each one of these points that we just made, but with an opposite R value, which we can start with our A, because we just did that. We just found this point E and A are the same on the polar grid. So if I write write the opposite of R, which would be negative 2, and then I want to I want to use that same point, but I want to have a different angle than 45 degrees. So if I start over at negative 2, so 0, negative 2, and I still want to go in a positive angle direction, then I would have to go all the way to 180 and then 45 more. So 180 plus 45 will get me my 225 degrees. So this coordinate negative 2, 225 degrees, that's the same point as angle A, but you have an opposite R value. Just gives you a different direction to go. Okay, we're going to continue trying that with each one of these. So B, the opposite of negative 1.5 is going to be positive 1.5. So I'm going to start. Where's my origin? I'm going over to negative 1.5. Or positive 1.5 this time because I want the opposite. And I want to end at B, but I'm going counterclockwise, remember, to stay positive. So I want to end all the way back over here at B, which is the angle 5 pi over 3. You guys confused yet? Okay, we'll keep going. Gotta keep trying it. Next point is C's at 3, so we're gonna go opposite of that and use -3. So 1, 2, 3, -3, and we want to end at C over here. But remember, we're gonna stay positive. So we're gonna go counterclockwise. So that is 90 plus 60. 90 plus 60 is 150. Okay, let's try again. Remember, you can always pause, try these on your own, and then check back in. Okay, D, we're going to start at -2.5. On to -2.5, because we're doing the opposite of R. And then we want to end at D down here. So not too far. So it should be a small amount. And what is the radians for that? Are you all yelling the answer? Pi/3? Yay! Okay, then E, we're going to use the opposite of 2. Oh, I think we already did this, but we'll do it again. So we're starting at 2, and we want to end up here at E, which is the same. How many degrees do we have to go up? Positively 45. That's the same answer that we got up there on A, or we started with on A. Sometimes it's helpful to go back and forth between polar coordinates and rectangular coordinates of, So to do that, we want to remember back when we were still using the unit circle, which we've never ended doing. On our unit circle, remember how each coordinate point on the outside of the unit circle, the x-coordinate was the cosine, and then the y-coordinate was the sine. And remember that happened because a cosine is the adjacent over the hypotenuse. So same thing with our polar coordinates here. We're going to start with cosine is adjacent over hypotenuse. So this R value is going to represent the hypotenuse. So sine of our angle is going to be opposite over hypotenuse. But to get our x, to go back to our x and our y coordinates for rectangular coordinates, we would then multiply both sides of our equation. So for the cosine here, we would multiply both sides of our equation by r. And so then we would end up with r times the cosine of theta, gives us what x is. And we would do the same process for multiply both sides of the sine ratio by r, so that we can get the y-coordinate as r times the sine of theta. So and this should look kind of similar. We've done this in several different situations. So hopefully they're all kind of connecting to you in a muddled mess in your brain, and you can use them a lot more next year in calculus. Woohoo! Or maybe you're going to go into air traffic controlling. So if we want to go from polar coordinates to rectangular coordinates, we're just going to multiply our r value times the cosine of our angle to get the x, and then the r value times the sine of the angle to get our y. You're just gonna kill it. This is gonna be no problem for you. Okay, so let's try some examples. So on example A here, we want to I'm gonna first find my x coordinate. So this is my polar coordinate I'm given. P is 4 and then pi/6. So to get my x coordinate of my rectangular coordinates, I'm going to multiply my r times the cosine of pi/6. And I love that unit circle. We're still using that unit circle. So handy. So check your unit circle for the cosine of pi/6. And you'll see square root of 3/2. And then we would simplify. We love simplifying our fractions. and we get 2 times root 3. We do the same process to get our y-coordinate. We're going to multiply 4 times the sine of pi over 6. So you look at your unit circle, or hopefully it's burned into your brain, and you're going to multiply 4 times 1/2, and so we're going to get 2 for our y value. So our polar coordinate was 4 pi over 6. Our rectangular coordinate is 2 root 3 comma 2. So this is our rectangular coordinate. Polar coordinate, rectangular coordinate. Easy peasy lemon squeezy. Let's try it one more time. Or you can pause and then check your answer. So for our x coordinate, we're going to start with the r value of -2, and we're going to multiply by the cosine of 135 degrees. Check your unit circle that's in your brain. Cosine of 135, negative root 2 over 2. Simplify, and we get positive square root of 2. Do the same thing. Y is -2 times the sine of 135. Sine of 135, positive root 2 over 2. Simplify, we get negative square root of 2. So then our rectangular coordinate is going to be square root of 2, comma, negative square root of 2. Yay! Can you believe it? That's it. That's all there is to it. Practice, practice, practice. And then there's also the Unit 10 review. That's really going to help you on your final exam, which is next week. Yay! So hopefully you've been doing a little bit of reviewing each day. Please don't wait. You're not gonna, please don't do the waiting till the night before to study for your final. Please, please, please. Oh my gosh, you guys. Anyway, please let us know if you guys need any help. You know where to find us. You guys are professionals at this distance learning. Good luck. Miss you. And we'll see you on Zoom when you take your final exam for sure, if not before. Okay, bye.